triple gasketing on the windows. Casement windows being the preferred window type because there's less areas to seal than there are with sliders or double hung. So casement windows are pretty regularly used in these constructions. So not only is the insulation important, but also everything else in there is important. So having super insulated and airtight minimizes what they call thermal bridging. And thermal bridging is also an issue because if you've seen many of the typical high-rise residential construction here in the city, concrete floors and balconies and that extend out to the perimeter and are exposed, these are like probably the worst cases of thermal bridging. And what typically happens from my past experiences, that the floors and ceilings around the perimeter of the building start to damage as a result of these radical temperature changes that are occurring because the cold or hot is coming directly in through the floor system. So you want to basically have a coat around the whole building, which is the insulation. So it would be the equivalent of trying to stay warm by, instead of putting the coat on the outside, swallowing the coat. It's not going to work the same way. So this is a project that I've been developing here in Brooklyn. It's going to be a model for passive house design, as well as a number of other certifications, including LEED and Living Building. What we're trying to depict here in our model is a building that really meets all of the tenets of the passive house design. And obviously you'll see here a very large gesture towards solar arrays, because not only will this building be a passive house building, but it'll also be a net zero building, which means all of the demand for the building's occupants and mechanical systems for common spaces, pumps and elevators and whatnot, will all be created by the building's solar and wind arrays. And again, you see in the section, very thicker walls. And these thick walls wrap around the whole building, including under the slab. The panel system that's shown here is what they call a SIP panel, structural insulated panel. They come in many different forms. In low-rise construction, they could be with a exterior OSB board between foam insulation. They could be, as we have it here, with metal. But basically, what this is your coat. And these panels interlock and basically form an airtight barrier as well as an insulation barrier. Typically, insulation values in these buildings are about twice what's normally expected in the code. Walls here in this job are R55 and roofs are about R80. So typically, that's a lot higher than the code would mandate, but that increase is what's saving the energy and keeping the energy inside the building. During construction of this project, we actually only had a little ceramic heater on the first floor heating the whole building during the time that they were actually working on it, and that was keeping the building warm. And the final heating system is actually simply electric mats in the bathrooms, and that does the whole entire heating for the building. And for a 6-unit apartment building, which this is, with a 1,000-foot commercial office on the first floor, the entire air conditioning load for the building is only 5 tons. Now that typically would have been about 35 tons if it was a conventional constructed building. Again, this is just showing the skeleton. Typically these buildings are a lot of times done in steel because it allows you to build the structure and then wrap the structure. When you try to do the structure and the envelope at the same time with something like masonry block or brick and block construction, it becomes a lot harder to actually achieve the airtightness and the barrier, because you're fighting between trying to seal off the penetrations for the structure and the envelope. So it's good to try to separate them, and that's what this red line around the entire perimeter depicts. And the thing you have to think about is that you really don't have to sacrifice any kind of a quality interior space or anything. This rendering on the right depicts one of the interiors of the apartments. These are multi-level units in some cases that have, you know, 2-story ceilings. What's nice here is you don't see a lot of ductwork, there's no perimeter radiation, there's no actual units. All you have is a concealed ERV with a small fan coil section that's being run off the geothermal wells. And again, this is another rendering of the shot from the interior at the level where the green roof is. So these are a number of certifications that people try to aspire to, LEED being one of them. This building will actually challenge to get what is considered to be a perfect score in LEED, Platinum, which is 110 points. It will also, it's in Energy Star for the multifamily rating, both water and air sense from the EPA. The Passive House Standard, which is FIAS there, Green Building Initiative, and Green Home, which is from the National Association of Home Builders. And then the one I consider to be the prize is the Living Building Challenge, which is out of Cascadia. And next week I'm going to be visiting their conference out there. The Living Building Challenge is a very, very exclusive certification program that only probably the finest buildings are in. If anybody would want to see one, there is actually one in our area that's up in Rhinebeck, New York. There's a yoga studio up there that actually achieved the Living Building status, but there's only about 5 buildings in there. And if anybody read the Times a couple of weeks ago, there's a building in Seattle that just got it, which I'm going to visit, called the Billet Center. So here's just a depiction of the segregation of the solar array on the main roof and just how it's organized. There's a lot of effort done here in the planning and execution of these jobs, but what happens with that is it makes the building run a lot smoother during construction. Here again on the right is the ERV unit, and then what you see here on the left, this is a unit that's unique to this particular project, but also has been used quite a bit. This is a desiccant dehumidification system. One of the problems you have with passive house buildings, especially here in this climate, is during the summer. These buildings are very slow to turn over temperature, so if you have spikes on the interior temperatures, it takes a while to adjust them. What the Advantix unit is doing is it's taking the outside air and passing it through a salt bath that's being charged, and that is basically dehumidifying the air. So we can take outdoor air during the summer months of 90 degrees with 95% humidity, drop the humidity all the way down to 20%, and then deliver that to the apartments. And at the same time, we're also going to be scrubbing the air. So we kind of colloquially say that the air in this apartment will be so clean that you would actually not even have to dust, because there won't be any airborne dust. One of the other tenets of the Living Building Challenge is how to deal with gray and black water reclamation on site. And one of the things we did, even though we're mandated to have a sewer connection based on the New York City code, we also have what's called a composting toilet system. So all of the toilets in the building go through this Aquatron system, which basically separates solids and liquids. Liquids are then treated and then sent to a biofilter in the front of the building, which is outdoors and cleaned by the plants. And the solids are left in the tank, which are broken down via red wiggler worms. So there will be a system here, and while it sounds kind of odd and difficult, the reality is that these guys do a great job of breaking down the solids, and they don't really need to be dealt with more than every 6 months, so it's not a heavy maintenance lift. And the good part is, at the end of the day, they produce a compost, vermicompost, that's like actually the best thing you can put in the garden. And we will use that on site as well as throughout the neighborhood. So this is the system. It's really a great system if you're in an area that doesn't have a sanitary sewer hookup. It's great for vacation homes, things like that. It's a little pricey for what it is, but it is a very simple system that's non-mechanical, and that's why we wanted to use it. Geothermal. So one of the things is how do you make up for any excessive demands that could happen? I mean, we are building a residential building here. We have to expect The gluttonous lifestyle of us in the United States here is such that, you know, people who live in a studio apartment might want to have a dinner party or a small gathering of 25 people in their apartment. At that point, the ERV system is going to basically go down because it's not going to be able to, you know, deal with that kind of a heat load from the people. So we have to supplement that. And we supplement that with an air conditioning system that actually takes its source of energy through the ground. And these wells that we put in are basically refrigeration tubing. So in lieu of having a condenser, like you would typically see on the outside of a house or a building, we have these wells under the ground. And that's how the temperature differential is achieved. And these are various ways of doing it, through ponds, the flat loop system, open loop system. We're more interested here in this area with doing a closed loop system, whether it be with refrigerant tubing or with water-based tubes, but that's typically what's used here. The other thing is we had a brownfield site here, and we went through the mayor's office's program on environmental remediation OER. I'll give them a plug. It was a really good experience for us. They sponsored a lot of the costs of the job. At the end of the day, as the developer, I was very happy in the fact that they give you a full exoneration of environmental liability, which now will get passed through to the customers that we will sell to. And in doing the system, we used a system that had not been done before here in the East Coast. If anybody's worked with Little E sites or sites that have been contaminated, typically the way to deal with that is to throw a heavy membrane across the site, pull your slab, and you're done. The problem with those systems are that the rising, you know, vapors or gases below the grade end up hitting the membrane, traveling horizontally, and all of your neighbors get the nice exhaust, similar to what happens when you come out of a tunnel at the end of the tunnel. All of the vapors and gases have nowhere to go but to permeate from the sides. So the system we put in, which is from Kuplex, is basically a ventilation system that works on a principle of draft. It goes under the slab is ventilated, and that's a continuous way of expelling any residual gases that may occur from the site. And here's a picture of the system going in. You could see the crawl space that we have next to it, which was from the old foundation, and you could see what is a white seam, and on the outside of the white seam, the insulation layer that's running around the crawl space. So it's quite thick, obviously, as you see. And this is the system of how we deliver the air. Remember I told you about energy recovery ventilation, but you actually have to get the air into the building through the energy recovery ventilators. So this is one of the ways that it can be done. Here we're taking the air from the exterior in the tube. It's going straight down into the ground. It's running horizontally in the ground in 3 loops of about 120 feet, and then into that machine, which is the dehumidification machine, the Advantix. The reason for running it under the ground, the air first, is you get a natural free 3 to 5 degree temperature drop or increase in the air. So if I'm bringing in air that's 90 degrees from the outside into the apartments, I could pretty much depend on about a 4 or 5 degree drop in temperature before I deliver it. So again, I have to use less energy to treat that air, and then conversely in the winter. At that point, it goes through the dehumidification unit, which actually runs in the summer primarily and not in the winter, and then it's delivered up to the apartments. And here it is with the unit being installed. It's interesting because we were experimenting, as we do, with a lot of different materials here, and you see the media that we used was a plastic pipe system with sand based around it, because you want a heat transfer or an energy transfer to occur into the ground. If you don't have that, it's not effective. Obviously, lighting is an important factor also, because, you know, energy demand and energy production, sometimes it's very difficult to get a balance between them. And net zero energy, which is the ultimate goal, is difficult when you have, you know, tenants or occupants coming in and bringing in, you know, 4 or 5 halogen torch lamps into their apartment, which are using, you know, gobs of electricity. So we made a point of installing recessed hi-hat LED fixtures, which we used a combination of traditional MR16 fixtures retrofitted with an energy efficient LED bulb, and this is how we're going to prevent people from using these typical incandescent or halogen lights. And that'll reduce the energy tremendously, because energy is typically the most used by lighting and climate control. So if you can control those two things, you'll do a lot to reduce the loads. So that's pretty much the presentation, and I wanted to basically have some good amount of time for people to ask questions, because I think it's important to understand how to do this system and to be comfortable with it. I believe really this job will help solidify it and these kind of construction techniques, and that's why I'm sponsoring the job. I think that most people really can't appreciate yet the value of it because they haven't really seen the hard data. So in an effort to get the hard data to everyone, we're installing a monitoring system that'll be on an iPhone app that we will share with the community that will show a daily usage at about 130 points throughout the building of what the CO2 levels are, what the temperatures are, what the differentials in temperatures are, and all of the facts and what this building will really produce. And one of the reasons we're doing that, not only to share the data, is because one of the certifications, which is the one we most prized, which was the Living Building Challenge, it's not like a typical LEED or one of the other programs where you do the check-offs and you submit everything and voila, you are LEED Platinum. Here you have to vet the building out for 1 year or 1.5 years to show that the building is actually achieving what you say it's achieving, and then and only then do you get the certification. So the monitoring becomes very critical to show and to actually make fine-tuning and adjustments, because again, lots of assumptions were made on the population, how people live, how many times they do their laundry, how many times they take a shower, how many times they'll wash their dishes. So all of these things are important and are all part of the whole sustainability movement, and that's one of the things we want to try to help in doing this building. So it's not only about energy conservation, it's a lot more than that. It's really about changing the dynamics of this model that we've created for ourselves. So with that, I'd like to ask anybody have any questions in the audience? Yes? Yes. Maybe you can stand up while you're saying, or just at least say it loud enough so people can
When
hear.
you're dealing with the older buildings where you're trying to preserve a certain amount of the old charm of, let's say, the brownstones, and you have exposed brick and things of that nature. I mean, I know you're never going to be able to achieve the energy efficiency when you're completely enveloping the building, but what are the trade-offs and what can you do to kind of balance between preserving the old look as well as trying to achieve the envelope?
Yeah, that's a great question, and that was one of my big thoughts when I got into the passive house movement originally. In cases where it really all depends on the level of renovation that's being undertaken. What I saw is a lot of painstaking detailing that people did around joist pockets and things with air seal tape to try to make an air sealed envelope. We have already done 2 projects that we're not certifying but have been done to passive house standards, and one of the things we did initially was in like a 3-story brownstone situation, we cut loose all the joists out of the joist pockets and put them on a bearing wall interior of the brick wall, and then basically created an air seal that way. We lost obviously the character of the masonry by doing that, but it was a trade-off by having a much tighter energy model on the building. In other cases, you can understand that you can get an air-sealed masonry wall condition, and if it's a party wall with your neighbor, that's okay. I mean, it only becomes an issue when you're on an exterior surface. So how you treat the exterior surface on a brownstoning application would be simply to add 4 or 5 inches of insulation on the exterior, and then putting on the brownstone application. So you would never really see the insulation, and it wouldn't change necessarily the character. There are about 4 or 5 really good jobs in Brooklyn that have been done that way. One in Brooklyn Heights that I know of, a couple in Park Slope, one in Williamsburg that you could research. And as a matter of fact, one of them actually went through the Landmarks Commission and used what is a mock double hung window that was created by one of the window manufacturers that if anybody saw it, they would think 100% it was a double hung window based on the setup of the sashes. But the upper section is fixed and the lower section is a casement. But it's set up exactly like a double hung, and it's a great window, and it does all that it has to do, and they were able to achieve the Passive House standards with that. But again, it depends. I mean, a lot of it starts just simply with the windows and sealing up around the windows, because that's where we see a lot of lax detailing, a lot of air leakage, and a lot of loss at that point. Anybody else? Yes, in the front.
Yeah, related. On the geothermal, what have you seen as far as opportunities where the land may be landlocked in the interior, or even digging wells in the basement of buildings, which I can't tell is urban?
Yeah, well, here in Brooklyn, we've experimented with a number of different types of wells. In my own personal residence in Gravesend, we actually installed a well in a finished house in the basement, and the water table is quite high there, and we're able to pull water on one side of the building and expel it on another, and get about almost 40 GPMs of water, which does the irrigation and a heat pump, and it works really well. One of the issues with open well systems is that there's a tendency to start to heat up the aquifer, and you got to be careful with that. Closed loop systems work well, and that's what we used in the job in Brighton. Typically burying the refrigeration lines in the ground does a great job of maintaining their temperatures at a 50 degrees, so you're not exerting the tremendous pressures that you would normally need to make the phase change of their conditioning, and that really tremendously drops the usage of electricity. But tight sites are a problem. That project that I'm talking about in Brighton is actually completely landlocked on all sides, practically speaking, with the exception of a small lane that accesses it. And we brought in, basically smaller drilling equipment and did it on our own. We actually used the environmental consultant's drill rig to actually drill down 50 feet and 75 feet for some of the wells. And there we had to be careful also, because in the early 1900s, we did an excellent job, our ancestors, of pillaging the water aquifer in that area, because they were using it actually for water, and they actually brought the salt water level way up, almost 25 feet higher than it used to be. So now we have to be careful about putting piping, especially copper piping, in a salt water environment. So we had to do relatively shallow vertical wells. Wells are expensive. Our experience with that was that all the well drillers that we dealt with, of which there were a lot of great ones, all are really on the bandwagon of charging whatever they feel like it, because they feel that the market will bear it, and people who want to do it will do it irrespective of the price. I think that a lot of that will shake out as more people start doing it, and the fact is that you don't really need to have a rocket scientist to drill a boring in the ground that's 50 feet deep with a 3 or 4 inch casing. So, a lot of this needs to really get traction by doing it more and more, and that's what we're hoping will happen here. Yes?
Bob, what effect does people opening windows and things like that have on the project?
Yeah, well, the fact of the matter is it's not meant to be a hermetically sealed building, and opening the windows is encouraged. What will happen is typically the energy recovery ventilator will basically disengage at the point sometimes when you'll open a window, and the reason for that is because you have the air that you want. Sometimes people just want to feel that breeze or that little cool air. But the reality is, when people open the windows traditionally, they're opening the windows because they felt uncomfortable in some way. So whether you're warm, or whether you're cold, or whether you feel groggy because it's the winter and the CO2 levels are spiking inside the building because there's no air movement, that's why you open the window. We created a cross ventilation system, and you can see in the picture you have windows here on the south and the north, and being that we're close to the ocean, you're going to get a nice continuous breeze. So yeah, we encourage that the windows be open, you know, in spring and summer. And quite frankly, we expect the windows to probably be open at times when they shouldn't be, like winter and summer, because of various conditions that people on the interior want to, which is why we have supplemental and backup systems. One of the things we wanted to make absolutely positively sure of is that this building would be foolproof and redundant. So while we use water to flush the toilets, we also have backup systems for that. While we use the sun to make domestic hot water to take showers, we have 2 or 3 backup systems for that, including the heat pump going in a reverse cycle to make it, and electric backups in the apartment and in this place. So when you're doing these systems, you know, it's important to recognize the fact that people are going to be people, and they're going to do what they're going to do, and you got to really be able to adjust for that kind of quickly and on the fly. So yeah, opening the windows is fine, and it's not discouraged. Anyone else? Yes?
I want to ask, you may have said, but how many units, residential units, is that? One, that's a single family home?
No, this is, this model that we're doing is a 6-family, and it has a 1,000-foot community office on the first floor. But the model can be done in either 6-family, multifamily. We just finished a hotel job in Greenpoint where we did the super insulated envelope, and you know, they're getting bills that are basically about 1/5 of what they originally budgeted for the hotel.
So do you have any estimate on the reduction in water consumption? Do you have any estimates on that based on that one? Or?
Well, they were using the city water, domestic water for their needs. Here we're using a water reclamation system to do flushing of the toilets, irrigation, and general maintenance needs. You're not permitted still to recycle the water to use for domestic purposes yet. Although I can tell you that there are people out there that we know that we've worked with that could basically take water from the toilet and make it drinkable, because that's what the military has been using in all of their instances for years. So it is possible. But at this point, domestic water reduction is what we're trying to do, and especially stormwater reduction in terms of discharge. Here we have little or no stormwater discharge. Anyone else? Yes?
Would you mind just talking about the cost of this construction and how that affects the pricing of units?
Sure. In the case of this model for us, we had a really interesting joke going around in our office about it, which was the fact that, you know, we had a thing where we thought that the actual soft costs would exceed the hard costs in this case. And one of the reasons for that being was the amount of research and development that we needed to do to understand these systems. There has been a lot done in this arena, but there still has a long way to go. And if you haven't really experienced it, it takes a lot to get up to speed. I think now the costs of construction for us here are somewhere in the $275, $300 range. And I would say soft costs not quite equal that, but high as well. We don't expect this to be any kind of development home run initially, but what the purpose of it is for the mantra of the Brighton Green, which is the name of the project, to be kind of branded and continued as a methodology for building any type of building, not only residential, but commercial, industrial. And we have a project in Jersey City now that we're doing, which is a simple self-storage building that we reduce the energy load there on the air conditioning system for the climate control building from 80 tons to 20. And that was all a trade-off directly on the envelope and the windows and the air sealing. So 60 tons of air conditioning went to pay for increases in the envelope. And if that balanced out, that's wonderful, because after that it's all gravy for the rest of the building's existence. Anyone else? Yes?
Talk a little bit about the maintenance requirements. It sounds like you have some very sophisticated systems in the building. I guess you're going to sell the building to people.
Yeah, one of the things we tried to do was to dumb down these systems as much as possible. Systems here work as they would work traditionally with a thermostat in someone's apartment. So you feel a little cool, you feel a little warm, you adjust the thermostat. Various systems start to come online and they go on and off. As far as, excuse me, the water reclamation and toilet flushing, there are backups that allow the system to switch out from one mode to another that basically happen themselves. And there is a budget number in the common charges that will allow for, you know, a maintenance, because these energy recovery ventilators in the apartments, they have filters, they need to be changed. We're not going to depend on the fact that people will recognize that they need to do that, and we'll have a schedule for them as when they could change those, so there'll be a person that comes around to do that. And obviously we can do that because that's all offset by the fact that, quite frankly, the hope is they'll have no electric bill, they'll have no gas bill, and they'll have no heating and cooling bill. So that savings could go towards some of the maintenance and maintaining the air quality. And the air quality, which I really didn't discuss too much, is sort of like an ancillary benefit to all of this, because again, I discussed CO2 levels, and one of the terrible things about living in the city here in a lot of places is you really can't open the windows. And if you do open the windows, you're subject to tremendous amounts of noise, dust, pollution, and various things. And the rates of asthma and bronchitis and all kinds of respiratory ailments is spiking tremendously throughout the city. And I think in Brooklyn, we have in certain areas of up at Star, East New York, and some other places which are still moderately industrial, we have some of the highest incidences of respiratory ailments in the country. These systems will do a great deal to purify the air, and the air quality will really be consistent with what you would see in a CCU or an ICU in a hospital. But yeah, there will be a lot of that, and these systems have been shaken out in other locations. There will definitely be a little more need for monitoring and watching, but the good part is the monitoring system will alert everyone to early problems. So, you know, if we see Mrs. Smith's temperatures spiking in her apartment, we could find out very simply by making a phone call to see if, you know, she's cooking for the whole family that day and she had all 4 of the induction burners going on, and, you know, had the heat turned up because she felt chilly because she didn't feel well, and, you know, kind of get instantaneous feedback, which is what you need to make this work. And I think in a lot of cases where there's faults in the mechanical systems, it's because there were no feedbacks. You know, no one finds out that one of the you know, the filters or the ductwork system vents were shut off until months later, or even years later, when there's some standard maintenance going on eventually. So yeah, it's a concern, but it's an addressable concern, we believe. Yes, anybody? Oh, yes.
The presentation before, you talked about how developers need to apply to a bank to get a loan. So if I'm a developer and I come and I say, well, where I would typically need a $200 square foot loan, I now need a $300 square foot loan. How do I sell that to a bank? And then also with what you just talked about, this big brother kind of approach, what would be a good, how do you kind of deal with that in terms of you're a developer, you're not the end user, you're passing the building on to other people that are going to use it. You can't really be discriminatory in who you sell to. So, yeah.
Yeah, well, obviously there were a lot of assumptions made in the design here as well as the demand and usage. And part of the issue with these kind of jobs is you really need to sort of decide on people's lifestyles to a certain extent. And we modeled that based on a variety of different data that we accumulated on buildings that were done like this and ones that weren't. As far as the monies to do it, I believe that the costs here that we experienced were subject to the fact that this was a very unusual and difficult site to work in, and that as time goes on, the price will become lower. but I believe that there's been an enhanced value, and there's a number of brokers in the community that have sold passive house jobs already that have, people have paid a higher premium for, and I think that the market itself, once they understand the fact that these buildings are of a much higher quality and a much better value for the money they spend, will do it. And then again, also the fact that typically, you know, some costs would have to be left for paying for electricity, heating and such, and if those are offset, that would free up additional monies to, you know, for the purchaser on the units. But yeah, generally, it's going to take a little time, but I think the fact that the market now is starting to be more understanding of this and worrying about their future bills and energy concerns, I think that'll go a long way to making it a viable solution in many cases, and lenders will understand it. Anyone else? Well, I just want to thank everybody for coming, and hopefully, you know, you guys are all in the forefront here of this, and I would suggest that in looking at projects that you do, or buildings, spaces, whatever it is, you know, try to keep an eye on making modifications that would serve generally to, you know, save energy and reduce energy, because believe me, people are asking those questions a lot more now. They want to know what their bills are. They're not just walking into situations without any concerns. And I know that over the years, a big issue with the condominium sales has been even in the quality of construction. Well, I can tell you that if you subscribe to these kinds of constructions where you use passive house technologies or construction techniques, one of the major benefits as a developer or a sponsor is going to be you're going to eliminate about 99.9% of the problems associated with typical construction, which are leaking windows, leaking doors, faulty mechanical systems, bad detailing, bad workmanship, because all of these things really cannot occur in a building that has been developed under these standards, because you would not pass an air quality test if you obviously had an opening that allowed water to get into the window frame. And this is something that we've seen rampantly going on. I mean, we even went so far as to develop a roofing technology here in this building where we're going to be able to deliver a 75-year warranty to the building occupants on the roof membrane. And this membrane system is out there. It wasn't really more expensive. It just required a little more of a technique on install and a little better monitoring and a little more effort. But, you know, I can't probably say how many jobs I've seen where initially after the first few years, the building's roof is already failing. So, you know, these are things we have to be aware of, and everyone here in this room really has a good opportunity to improve their situation, and it becomes sort of like a chain reaction, because once you start improving in one area, you look to other areas, and it becomes sort of like a cycle of, you know, effect. So I encourage everyone to do that. My office is, you know, going to be sharing this data eventually, having visits on the site. I myself concentrating on doing these developments now because I think, you know, people need to see it. They need to touch it. I'm still also of the opinion of, you know, I have to feel, because it's Ascension Thursday, I have to feel the pulse. I gotta know that this is really gonna work, and I gotta know it's something that makes sense and is affordable and buildable and it can be done. I remember, just as a funny aside, one of the first things that I said, or someone said to me when they were doing was, well, how possibly can you get the air sealing done? You know, we have some of the worst people building jobs, and they're rushing through them, and they're trying to do everything on the cheap. And I said, well, you know, it's kind of like the water delivery system in the building. And no one, I don't think, in this room would accept the plumbing system water delivery to be leaking, right? Because it would destroy the whole interior. So somehow the plumbers have managed to figure out a way to make sure that they can deliver a water system that doesn't leak. So it's just the next step with the air. Thank you.